Hello everyone, and welcome back to our channel. Today, we will build an object-triggered image capture system. This project combines distance sensing with camera capture. When an object comes within 20 centimeters, the system captures a JPEG image and makes it available on a web page. The page updates in real time to show the current distance and the captured image. The system interfaces with an HCS-R04 ultrasonic sensor for distance measurement and an W6300 camera module for image capture. We will use the W6300-EVB-Pico2 as our main controller. This board integrates a Raspberry Pi Pico 2 with a WIZnet W6300 Ethernet module, providing both processing capability and network connectivity in a single unit. Let's proceed to examine the hardware and circuit connections. These are the components we need for this project. Several resistors are also required. Before we begin building, there's some preparation we need to complete. If you haven't set up your board yet, please watch our previous setup video first. Once your board is ready, you need to ensure you've downloaded the correct libraries to your board's lib folder. The three essential libraries for this project are Adafruit_WIZnet5K for Ethernet connectivity, Adafruit_HCSR04 for the ultrasonic sensor, and Adafruit_OV2640 for controlling our camera. Now, let me show you how to connect everything together. The HCSR04 ultrasonic sensor operates at 5 volts, so its echo output is also 5 volts. However, the Pico board's GPIO voltage input range is only 0 to 3.3 volts. Therefore, the echo voltage is too high and requires a voltage divider. We use a 10,000 ohm resistor connected between the echo pin and the GPIO pin, and another 10,000 ohm resistor connected between the GPIO pin and ground. This configuration lowers the voltage to 2.5 volts, which is within the safe operating range. The camera connection follows the same configuration as our previous project. I have a circuit diagram on screen that you can reference for all connections. Now, let's examine the circuit connections. Always remember to double-check all your connections before powering on. A quick visual inspection can prevent short circuits and protect your components from damage. For the software implementation, we follow a complete logic flow that begins with system initialization and proceeds to the main operational loop, which handles detection, image capture, and web serving. The code starts by configuring the Ethernet connection using the same setup as our previous project to establish network connectivity. Next, we configure the camera to operate in SVGA JPEG mode, which provides a good balance of image quality and performance. The ultrasonic sensor requires specific configuration that differs from the standard Adafruit library example. We set the timeout to 0.5 seconds and connect the trigger pin to GPIO27 and the echo pin to GPIO26. Several key variables are initialized to manage the system state: the latest captured image, current distance measurement, a flag to control image display, a timestamp for the last detection, and a cooldown period to prevent rapid repeated captures. The system defines several core functions. The measure distance function reads the ultrasonic sensor and returns valid distance measurements between 2 and 400 centimeters, returning none for failed readings. The capture image function captures JPEG data from the camera. The send HTML response function generates and transmits the HTML web page, displaying the current distance with color-coded background indicators, showing either the captured image or a placeholder message depending on detection status, and including an auto-refresh mechanism that reloads the page every 2 seconds. The send image response parents function efficiently transmits captured JPEG images in 2048 byte chunks to handle larger files over the network connection. After establishing the server socket, the main loop operates continuously with 3 primary responsibilities. First, it performs DHCP maintenance every 30 seconds to ensure stable network connectivity. Second, it monitors distance measurements every half second, checking the ultrasonic sensor and triggering image capture when an object is detected within 20 centimeters, provided at least 1 second has elapsed since the last detection. This process includes image validation and LED indication. When no object is detected, the system clears stored images and performs garbage collection. Third, the system handles incoming HTTP requests by listening for browser connections, serving captured images for request to /latest.jpg, and delivering the main HTML page for all other requests. Let's see it in action. First, we need to wait a few seconds for the server to initialize. After the server indicates it's ready, we can access it by entering the IP address in a web browser. I have placed an object in front of the device, and the system continuously updates the distance measurement between the object and the sensor. When I move the object closer and the distance drops below 20 centimeters, the camera immediately captures an image. The web page updates to display the captured image, and the interface changes to a red color scheme to indicate object detection. The status message updates to show an alert state. If I pull the object away beyond the 20 centimeter threshold, the page automatically changes back to a green color scheme. That concludes our project. If you enjoyed it, please like this video and subscribe for more IoT tutorials. All code and diagrams are available in the description. Thank you for watching. See you in the next video. Goodbye.